Alright, so I had to create a second video here for the last couple of problems. So for part C, this is going to be an alternating series test. Now the first part is to show if it converges or diverges, that the limit as n approaches infinity of b sub n should be equal to 0, or b sub n is going to be n divided by 4 to the n. If I do the limit as n approaches infinity of n divided by 4 to the n, this is a scenario where it's going to look like infinity divided by infinity, like the indeterminate form. So I should take the derivative, use L'Hopital's rule. This would be 1 over the natural log of 4 to the n, which the limit for 1 isn't going to change, or 1 isn't going to change as n approaches infinity, and our denominator is approaching infinity. So this is equal to 0. The second part is hard to show that it's decreasing. So I taught that it was b sub n plus 1 is less than or equal to b sub n. In this case, it's going to be difficult to show. Another way we can show that is to take the derivative and show that it's going to be less than 0. That's going to be negative. So I'm going to do it on the side over here. We're going to need to do the quotient rule for the n. So the derivative of n is 1. If f is n, f prime is 1, g is 4 to the n, g prime is the natural log of 4 times 4 to the n. So low d high 4 to the n times 1 minus high n times the natural log of 4 to the n, all over 4 to the n squared, which looks like crazy at first, but if you notice, we could factor out a 4 to the n in the numerator. 4 to the n times 1 minus the natural log of 4, which is just a number, n, over, if this is 4 to the n squared, this is 4 to the n times 4 to the n. These are going to cancel. And I'm left over with the 1 minus the natural log of 4 over n. So when I am looking for when is this going to be less than 0, four n over 4n is less than 0. I would multiply both sides by 4 to the n. These cancel, and I get 1 minus the natural log of 4n, which is just some number n, is less than 0, or I could add the natural log of 4n on both sides to get 1 is less than the natural log of 4, then divided by the natural log of 4. When n is greater than 1 over the natural log of 4. Now, e is pretty close to 3, so 4. This number is going to be less than 2. We're starting at 2, so this is going to be decreasing for all the values that we have in here, so this will converge. I know that looks like a lot. I think it's doable. Just don't forget the quotient rule. For d, this is 2 to the n factorial, 2n factorial divided by n factorial squared. Anytime you see factorials, please think ratio test. So the limit as n approaches infinity of the absolute value of 2 to the n, I'm going to write this out longer, 2 times n plus 1 factorial over n plus 1 factorial squared times n factorial squared over 2n factorial. Now 2 times n plus 1 should be rewritten as the limit as n approaches infinity, absolute value of 2n plus 2. All of that is factorial divided by n plus 1 factorial squared times n factorial squared over 2n factorial. Okay, so with 2 to the n plus 2 factorial divided by 2 to the n, I'm left over in the numerator 2 to the n plus 1 times 2 to the n plus 2. over here with n factorial divided by n plus 1 factorial. Both of those are squared. N factorial divided by n plus 1 factorial is going to be 1 over n plus 1 squared. So my denominator, it's like n plus 1 squared. So I don't care about what the other terms are. This is like where I would look at the leading coefficient and the degree. This is what you guys learned in the pre-calc, like, the each DC. The leading term here is going to be 4n squared, and we're dividing by an n squared. So this limit is going to be equal to 4, which tells me that this is going to diverge. Because for the ratio test, if the limit as n approaches infinity of a sub n plus 1 divided by a sub n is greater than 1, it diverges. If it's less than 1, it converges. And that's why when we try to figure out what the radius of convergence is, we set it less than 1. The last one here, I'm going to do the test for divergence, because I don't believe that the limit is equal to 0. So again, this test only tells you if something diverges. You cannot prove that something converges because the limit equals 0. So if the limit as n approaches infinity of a sub n does not equal 0, then the series a sub n diverges. And the limit as n approaches infinity of 3n plus 6 over 5n equals 3/5. So this diverges. All right, I think we've gone over every single question in class. If you have any questions, let me know. Don't forget to bring in the book. Good luck tomorrow, and I'm really excited to see how this all goes.